Okay, so before we start, I give you a quick introduction of myself. My name is Wolfgang. I'm a plastic engineer. Started with plastic when I was 21, and have meanwhile over, well, not over, exactly 40 years of experience. So now you can do your math on that. And after university, first job was in the industry at a company called Braun, which is now belongs to Procter & Gamble. And then I moved to the other side, to the raw material side. Was a long time with Celanese in various roles, and then ended up since 12 years, meanwhile, at KD Feddersen, which is a European plastic distributor. Oh, this was the wrong one. Okay, just a brief introduction and overview of who we are. So the company has been founded in 1994, just a few years after the World War II, with some basic import, export, and local trading between the northern part of Germany and Denmark at that time. About 10 years later, our founder, Carl Detlef Feddersen, signed a big contract with one of the three big chemical producers and plastic producers, which was Philips, which does not exist anymore, but at that time it was. And that was the start with the plastic business. So it was 1995. So meanwhile, since over 60 years of dealing with plastics, we have been growing. So we are serving whole Europe, still except Italy, but that will be fixed most probably by next year. So we are covering whole Europe, Turkey, as well as the northern part of Africa, which is a Maghreb state. And not only that, the distribution has been grown. We are meanwhile in a holding structure, so a big group with various businesses globally, and we are almost 1,000 people in total with almost 1 billion of revenue. So we have grown since the beginning of 1994. Again, wrong direction. Yeah, so you have seen that already. So this is in a nutshell the summary of the basic performance and properties of polyketones. So the mixture on the combination of the high crystallinity with the high toughness that the material brings with it, and all the regulations that we've seen for drinking water and food contact, as well as with the exceptionally good tribological performance, plus low VOC, plus the capability that we can add flame retardant to the product and still have a very tough product, makes it a nice combination. And it's interesting that the material is still, although it's on the market for 10 years meanwhile, so when it has been reinvented, so to say, by Hughes 10 years ago, and it's brought into the market, and it's still widely not known, still widely unknown, although it has a very nice combination of properties. Just one example, the natural polyketone is, in terms of the slip and wear properties, almost as good as the best modified UN. So it's a really exceptionally perfect product when it comes to slip and wear clips and everything else. So it's one of the really unique properties of the material. So coming to one of the first case studies we have with caster wheels, and it has already been mentioned. So in that specific case, it's heavy-duty caster wheels. So caster wheels are, so to say, made with nylon 6 since decades, and it's the standard material that's used widely. And we had a customer, family-owned business, smaller privately held customer that is acting as an OEM. So they do their own development, they do the manufacturing, they do the selling, and they sell globally. So they are one of the market leaders on that, and they had an issue with their heavy-duty caster wheels with nylon 6. So we had a chance to test polyketone against it in the same tool. We were supporting them several days with molding trials, and we could speed up the cycle time by 50%, so which is a huge step, and you've already seen it, that it's possible, and I will explain later a bit why this is possible with it. But this was not the major driver for the customer. It was the driver that the mechanical properties that they had been testing then with this application. So that means that all the lifetime testing, it was a fuse test, maximum stress test, it was maximum load test, it was boiler fatigue, and everything else, all the long-term testing that they have done. And there they found, depending on the test, an improvement of 30 to 40% over their nylon material that they have been using since decades. So now they are stepping in for that heavy duty caster wheels and replace it by polyketone. And this application will be multiplied within that customer step by step when they learn more about polyketone. So this was kind of a success rate, success case. And also the customer did not know that polyketone was existing, and he was really surprised to see how the performance of the material was in comparison to nylon 6 that he uses since decades. Another application, we've already seen it, that is some kind of number one application in the automotive industry is high voltage connectors for e-mobility. So typically the materials are used are nylon based, so nylon 6,6, some PPT, also some PPA materials are used as well as polyketone. Standard material is glass fiber 30 with a flame retardant system that enables to reach V0 plus orange color, which is needed for that to make it optically clear that this is high voltage applications. And polyketone for me, polyketone is the superior material because it has significantly higher toughness than all the other materials that are used. And I've made a comparison with the strain and break. You can see that with various materials that are listed, so not only these two materials here that are used, but I've also just for comparison added a few others, and you can see that the margin that the material gives after glass fiber and flame retardancy is that you have twice as much as elongation at break. And typically, when material is aging over time with heat and time, so the material and parts typically break due to brittleness. And here you have a huge safety margin in terms of long-term application as well as for all the clips. So it's twice as much as every other materials. Okay, coming to the colors, usually the customer in that case prefer to have mass colored material, but in some cases it needs an additional step of compounding. And as we've already heard that polyketone is kind of sensitive in terms of thermal load, you can save that step. And instead of using a mass colored material, you can add a master batch. And one of our sister companies, AF Color, developed a lot of various colors based on the original polyketone base polymer. So there's no carrier material that's a polyolefin or something else. It's the original polyketone material, and it's a wide variety of colors with selected pigments, and you can find also the orange color on the top level. I think I need. Sorry. Okay, the last case study is a recent one that we just, so to say, realized and won, which is in the industrialization phase, where they have to phase up and build a new tool. It's also family owned small business, kind of hidden champion in the southern part of Germany. They are considered as the market leader in data networks, data management, and they have brought out a new series application for fiber trays. So this is pretty much a big topic in Germany, that we are building our glass fiber network for internet to get a broader range. The part we are talking of is about this one, this flap here. So there are many put into that device, and then the whole network is then used to distribute that within buildings or within communities. So it's a highly complex application. In total, the whole assembly, and we're using here a unfilled polyketone with just with flame retardancy with 0. It's a custom color with mass colored special white for that customer, and the combination is PFAS free and allergen free, and the customer was using in the past predominantly ABS material. This first dry, but with the new requirements for that application, ABS regulated. So we had a chance to discuss with him and introduce also polyketone, which was not known to him. And also here, we supported the molding trials and could speed up the cycle time by 50% versus ABS, and this is a thin wall part, so with just 1 millimeter. And the caster wheels, for example, were thick wall parts where we are talking about cycle times of minutes since the parts are several centimeters thick. So, and for the customer, it was the combination of the mechanical performance. So a lot of still a lot of sharpness is left over. So with that combination, unfilled, you have 40% of elongation at break with the material still is 3-0. So that was one point for the material, yeah, so they've done their extensive testing and now they are scaling up and they built a new four cavity tool, to my knowledge. And what I heard, they should be in contact with you. As far as I heard, that they are switching to a full hot runner system, and it will be a full hot runner system. Coming to the molding conditions, we already heard it. So we've done a calculation where we did a basic calculation here on the example with a 2 millimeter wall thickness, just to see what the minimum cooling times is in a comparison of polyketone versus various other polymers. These are just unfilled polymers. In the next slide, we have 30% glass fiber. And you can see what already has been mentioned, that polyketone is about the fastest cycling materials. And there are two reasons for that. One is the thermal aspects, that the heat transfer is quite quick. And the other one is that the speed of crystallization of the material is exceptionally fast. And that makes it a really super fast cycling material, which adds, besides the performance and properties of the material, adds also a big step in economical benefits that the customer can get. But this needs to be, so to say, supported in the molding trials, really to squeeze out what's possible. And we've proven several times that we can speed up the cycle time up to 50% compared to other polymers used. And here's a comparison with 30% glass fiber material. And there's only one material on the market that is known to be the fastest one, which is a liquid crystal polymer. This is by far the fastest material, and you can see in that comparison that polyketone is the second fastest. And especially in the combinations with glass fiber, you can really run it exceptionally fast. And this gives a significant economical benefit, and that's what we have proven several times, especially when we are supporting our customers in terms of molding trials. Okay, coming to, yeah, of course.
And then at the end of the process, in terms of the constructions, the molds, in terms of the contractions in the mold, what shrinkage,
Yeah.
exactly. What would be the one-to-one then?
It's pretty comparable against POM, against PBT, against nylon, maybe plus minus 0.1%. But pretty much you can say you can run it in the same tools. Maybe with well, when you have some really tight tolerances, you might do a correction in the tool, but as a baseline, it is pretty much one-to-one changeable. And when you have the glass fiber, then it's even more close to it. So usually there's no need to change. Maybe a little bit optimization in the runner system or so, but not in the cavity itself. So it's an easy replaceable material. so that you can use the tools you have and switch over to that material, at least for the trials, and usually it works without any issues that you have. It's a benefit, it's more or less 2% breakage plus minus, and it's very similar to BUM, PBT, and nylon. That's our experience. Speaking about the injection molding, so polyketone is a little bit sensitive in terms of the thermal load, so it's time, temperature, and energy you bring into the material in the molding process. So in order to learn a bit more, besides what we experienced with our customer, we were partnering together with ABUC and with Günther Hartrunner, 1, 2, 3, I think 2 years ago, roughly, yeah. And we supported a bachelor thesis at ABUC, which is one of the German famous injection molding machine manufacturers, in order to learn a little bit about the root cause and main effects of processing conditions on the performance of the polymer in terms of degradation, black stacks. That's something that we already heard from Woody. And based on that, what we found there, and we've done several rounds of tests, and I think it was in total about 5 days that we were there, over 1.5 years. We come up with a recommendation for processing, which is a little bit different what you find elsewhere. So we have a few points here and there where we learned, in order to really max out what's possible, just to squeeze it here and there. And if you want to know it, you can ask later or come to our booth, and then we can have a discussion on the points that we found out where we turn the knobs in a little bit a different direction than many others. Okay, so in a nutshell, polyketone still a widely unknown material, but the combination of the properties and the performance makes it a highly interesting material and a perfect alternative to the well-known engineering polymers like PUM, like PBT, and nylon. So that's in a nutshell. And in many cases, we use polyketone as a troubleshooting material when there are some issues with these existing materials. Then polyketone is in many cases a solution for that. Any questions?
Thank you very much.